A star's farewell, the beginning of the end. Stars appear eternal, their light traveling across the vast expanse of space. They light up the night sky for millions, even billions of years, casting their glow on countless worlds. But even these cosmic giants don't last forever. Their brilliance is finite, destined to fade. Like us, stars have a life cycle. They are born from clouds of gas and dust, igniting into fiery beacons. They shine brightly, illuminating the cosmos, and eventually they die, leaving behind a legacy. But their deaths are far from mundane. They are cataclysmic events that reshape the universe. These spectacular events can outshine entire galaxies, creating a cosmic spectacle. The death of a star isn't just an ending, it's a transformation, a rebirth of sorts. It's a cosmic recycling process that gives birth to new generations of stars, planets, and even life itself, continuing the cycle of creation. So what happens when a star dies? The universe has a fascinating story to tell. The answer is a tale of nuclear fusion, gravitational collapse, and the birth of some of the most extreme objects in the universe, like neutron stars and black holes. Let's embark on a cosmic journey to uncover the fascinating ways stars meet their demise and the wonders they leave behind. From the quiet fade of white dwarfs to the explosive power of supernovae, each death is unique. The universe puts on a breathtaking show when a star takes its final bow, a testament to the endless cycle of life and death in the cosmos. To understand a star's death, we must first understand its life. Stars are born in vast clouds of gas and dust, known as nebulae. Stars are giant balls of hot gas, primarily hydrogen and helium. These elements are the building blocks of stars. Deep within their cores, a process called nuclear fusion occurs. This is where the magic happens. Imagine hydrogen atoms smashing together at incredible speeds, fusing to form helium and releasing tremendous energy in the process. This fusion process is the powerhouse of the star. This energy is what makes stars shine. It's the reason we see them twinkling in the night sky. Think of a star's core like a giant cosmic furnace. This furnace is incredibly hot and powerful. The hydrogen fuel keeps the furnace burning, generating outward pressure that counteracts the inward pull of gravity. This balance is crucial for the star's stability. This delicate balance between pressure and gravity is what keeps a star stable. Without it, the star would collapse under its own weight. However, this balancing act cannot last forever. Over time, the star's hydrogen fuel begins to deplete. A star's lifespan is determined by how much hydrogen fuel it has. The more massive the star, the shorter its life. Larger stars burn through their fuel reserves much faster than smaller stars. This rapid consumption leads to a shorter, more intense life. Eventually, the fuel starts to run out and the star's internal furnace begins to sputter. The once stable star starts to change dramatically. This is when a star's life takes a dramatic turn, leading to its eventual demise. The end of a star can be as spectacular as its life, often resulting in a supernova or even the formation of a black hole. For smaller stars, like our Sun, death is a gradual process. As the hydrogen fuel dwindles, the core contracts, heats up, and the star expands into a red giant. Imagine a dying ember in a fireplace, flaring up one last time before turning to ash. That's a red giant, a star in its twilight years. Eventually, the outer layers of the red giant drift away, forming a beautiful cosmic cloud called a planetary nebula. What's left behind is the star's dense core, a white dwarf. Imagine a sphere the size of Earth, but with the mass of our Sun. That's how incredibly dense white dwarfs are. White dwarfs slowly cool over billions of years, eventually fading away into faint, cold objects. It's a quiet, unassuming end for a star that once shone brightly. But it's a common fate for many stars in the universe, including our own Sun. While smaller stars fade away quietly, massive stars meet a far more dramatic end. These stellar giants, much larger than our Sun, burn through their fuel reserves at an astonishing rate. When their core runs out of hydrogen, they start fusing heavier elements like helium, carbon, and oxygen, all the way up to iron. But fusing iron requires more energy than it releases, and this throws the star's internal engine out of balance. The core collapses in on itself in a fraction of a second, triggering a shockwave that rips the star apart in a colossal explosion known as a supernova. Supernovae are among the most energetic events in the universe. For a brief period, a single supernova can outshine its entire galaxy. They are also responsible for creating and dispersing heavy elements into space, the very elements that make up planets and even us. Section 5. Stellar Ghosts, the mystery of neutron stars. After a supernova explosion, the star's core is left behind. If the core is massive enough, it collapses further under its own gravity, squeezing protons and electrons together to form neutrons. What remains is a neutron star, an incredibly dense object the size of a city, but with the mass of our sun. Imagine a sugar cube weighing as much as Mount Everest. That's how dense neutron stars are. They spin rapidly, emitting beams of radiation from their poles. If these beams happen to sweep past Earth, we see them as pulsars, blinking on and off like cosmic lighthouses. Neutron stars are still shrouded in mystery. Their extreme density and gravity make them perfect natural laboratories to study the fundamental laws of physics. Section 6. The ultimate end, the insatiable hunger of black holes. If the core of a massive star is large enough, even the immense pressure of neutrons cannot withstand the crush of gravity. The core collapses endlessly, forming a black hole, a region of space-time where gravity is so strong that nothing, not even light, can escape. Imagine a cosmic drain, pulling everything around it into its depths. Black holes are invisible, but their presence can be detected by the way they warp the fabric of space-time and influence the motion of nearby stars and gas. Black holes are the most extreme objects in the universe, pushing our understanding of physics to the limit. They are regions of infinite density and zero volume, where the known laws of physics break down. Section 7. Cosmic Recycling, the legacy of star death. While the death of a star may seem like an ending, it's actually a new beginning. The material ejected during a supernova explosion, enriched with heavy elements, eventually becomes part of new stars, planets, and even life. The atoms in our bodies were once forged in the fiery hearts of stars long gone. Think of it as a cosmic recycling program. Stars are born from the remnants of previous generations of stars, creating a continuous cycle of stellar life and death. This process ensures that the universe is constantly evolving, with new generations of stars and planets forming over billions of years. The death of a star is not simply an ending. It's a crucial part of the grand cosmic cycle, enriching the universe and providing the building blocks for future generations of stars, planets, and life. Section 8. Our Sun's Fate. A glimpse into the future. Our own sun, a middle-aged star, will eventually meet its demise too. In about 5 billion years, it will exhaust its hydrogen fuel and begin to expand into a red giant. Its outer layers will engulf the inner planets, including Earth. Don't worry though. Humanity has plenty of time to find a new home among the stars. After its red giant phase, the sun will shed its outer layers, forming a planetary nebula, and its core will shrink into a white dwarf. This white dwarf will slowly cool and fade over billions of years, marking the end of our solar system as we know it. While it's a sobering thought, understanding the life cycle of stars, including our own, allows us to appreciate the vastness and beauty of the universe and our place within it. Section 9. Conclusion. Star death, a universe renewed. The death of a star is a testament to the universe's incredible power and beauty. It's a process that has fascinated astronomers and stargazers alike for centuries. From the quiet fade of white dwarfs, which slowly cool and dim over billions of years, to the explosive power of supernovae, which can outshine entire galaxies for a brief moment, the way stars end their lives shapes the cosmos around us. These dramatic events leave behind remnants that influence the formation of new celestial bodies. These events are not just destructive, but also creative, giving rise to new star nurseries and cosmic dust clouds. Seeding the universe with the building blocks of new stars. which will eventually form new solar systems, planets, and potentially life. The cycle of star death and rebirth is a fundamental aspect of the universe's evolution. As we continue to explore the universe, using ever more advanced technology, we'll undoubtedly uncover even more secrets about the fascinating ways stars die. And with each discovery, we learn more about the life cycles of these celestial giants. We gain a deeper appreciation for the intricate workings of the cosmos and the delicate balance that sustains it, and our place within its grand design. We are all part of this cosmic story, connected by the same elements forged in the hearts of dying stars. The next time you gaze up at the night sky, remember that even the seemingly eternal stars have a story to tell. A story of life, death, and transformation. A story of life, death, and renewal that continues to shape the universe we call home. The universe is a vast, ever-changing tapestry, and we are privileged to witness its wonders.